Now this illustration deals with the number of conductors in cable trays and raceways and ampacity adjustment factors. In accordance with NEC 725.51 A, B, and C. Now, let's talk about the transformer first at the right-hand side of the illustration at the top, titled Control Transformer, Class 1 Circuit, and it lists that it could be power limited by 725.41B, it would be a circuit of unpower limitations by 725.41A. A Class 2 and Class 3 circuit can be examined in detail by looking at 725.121 and looking at the power output of these circuits in Table 11A and B to Chapter 9. For example, a Class 2 circuit could operate anywhere from 0 up to 50 volts. Volt amps and volts, but notice you would go to the table to determine their output. A Class 3 circuit, for example, could operate from 50 volts up to 150 volts and have the outputs listed in there just as well as for the Class 2 circuit. But the voltage that we're looking at that transformer on the secondary side of it is 0 to 30 volts as illustrated. Now notice for re-identification of the circuits, we'd look at 725.130A exception 2. And then notice we have conductors and EMT with the arrow pointed to it that are 3 power conductors and 2 control circuits. The 3 current carrying conductors, we naturally would review Table 310.15C1, and we are allowed 3 current carrying conductors without derate factors. But Table 310.15C as in car 1 tells us that if we had 4 to 8 conductors that are current carrying, then it's 80% derate, 4 to 6, excuse me. And if you have 7 to 9, it's 70%. And then, those percentages go up 50% and so forth. Now, the control circuits are number 14, AWG, 1 amp each is all they're pulling to energize that coil and power up the motor, say. Now, going over to the information to the left-hand side, right-hand side, or left-hand side of the illustration. Notice we are finding the maximum amps before the control circuits are current carried. So we're using Table 31016 and the 2020 NEC, and a number 14 conductor is good for 20 amps to us in the say the 60-degree column or the 75-degree column, the column that we're using. And in step 2, we're finding the maximum amps. 725.51B as in boy 2 has the 10% rule. So we would take 20 amps, take 10% of it. We're allowed 2 amps that we can use. And notice in the control wire identification, right-hand side of the contactor, the number 14 is only loaded to 1 amp. So the solution is an answer. The 1 amp on each control circuit is less than the 2 amps that are permitted in step 2. So there's no adjustment factors required. And as long as your phase conductors do not pull more current than the conductors allowed to pull, and you only have 3 current carrying, there's no derating there. Now from the OSHA standard, OSHA 1910 subpart S, notice we could have circuits that are unpower limited by voltage ratings of 120, 208, 240, 480, 550, 600 volt. To the right now we have power limited circuits, and notice they could start from 0 to 20 volts, over 20 volts to 30 volts, over 30 volts to 60 volts, over 60 volts to 150 volts. And then we call out in this work in note 1, C725.121A and B, and 725.41 for control circuit voltage limitations, and in course table 11A for AC control voltage ratings, and 11B to table to the table in chapter 9 for DC. We would pick up output ratings of these circuits based upon them being class 2 or class 3. Class 1 spelt out for us in 725.41A or B. So figure 4-16 is actually listing the number of conductors permitted in cable trays, raceways, without any ampacity adjustment factors based upon the number pool, if there's 3 or less or 4 or more for derating and adjustment factors for current carrying conductors for the power, and then the 10% rule is applied for the control circuits. So we pick these rules up in this section, 725.51A, B, or C, and in course figure 4-16 gives you a complete illustration pertaining to these rules and these requirements.